A lot of RVers and cruisers are getting excited to ditch cellular and switch to Starlink satellite based on all the buzz and excitement, but I'm here to give you a bit of a reality check on what to expect and when. Hi, I'm Chris with the Mobile Internet Resource Center, here to give you an update on Starlink. Now, if you haven't been following along for the past several years we've been covering this, Starlink is SpaceX's low Earth orbit satellite constellation that is in the process of being deployed. And it is unlike anything that has come before it in space. So rather than just one satellite over geostationary orbit sitting there over the equator in one fixed place, or a constellation of just a few dozen or 66 in the case of Iridium satellites, Starlink is aiming to build a constellation of thousands of satellites, eventually up in the tens of thousands of satellites, at such a low altitude that they can give latencies and speeds theoretically rivaling 4G and 5G, but with global coverage. It sounds almost too good to be true. Low latency, gigabit speeds, and coverage anywhere? What's the catch? Well, we're going to give you some of the catches and an update on where Starlink is right now, because this is very exciting technology, but some people are getting a little bit too excited and not thinking through some of the downsides, particularly the initial downsides. So first up, what's the current status of Starlink? This past Wednesday, SpaceX launched another batch of 60 satellites, bringing the total Starlink satellites launched up to 480. The first 60 were test satellites, so they're up to 420 satellites in orbit. Wow, that's a lot. They actually now have the biggest satellite constellation in existence of, even governments. It's a huge network. But they still have a long way to go. SpaceX says it will take 720 satellites to give coverage over the main bulk of the continental United States, 1,440 satellites to cover most of the populated world, and 1,800 satellites, so 30 launches worth of satellites to be able to give true global coverage. So they've gone a long way, but they still have a long way to go. And even launching 60 at a time, it takes a while to build a network this big. And now, by the nature of these low Earth orbit satellites, they converge over northern Canada. And as they add more, the coverage fills in down from there. So they will actually be able to start offering service in the northern parts of the United States and Canada, and in northern Europe and such, later this year, before they have the full 720 deployed. That will be happening relatively soon. In April, Elon Musk said that they're going to start a private beta, presumably for SpaceX and Tesla employees and friends and family and coworkers and whatnot, starting that in 3 months, probably in a July-August time frame. That's when they'll have enough satellites to start turning on service, and a public beta in 6 months, probably roughly around October-November time frame, and signing up people in the northern parts of the United States and the country to start testing this service out. So people are getting excited. They're like, wow, we can sign up for this. I want to be part of this beta test. How do you do this? Well, no details on that available just yet, but no, it will be starting the northern parts, like Seattle north, Canada north, and then filling in from there. And it will probably be invitation only or application only, based on filling in just certain select areas. They'll be testing in various places and stuff. So don't get too excited about being able to sign up for Starlink in 2020. Exactly. In 2021, there will probably be a lot more coming from Starlink. And that all depends on how well the beta test goes, and of course, it's space. So are there going to be any issues with launches, with delays, and anything like that? So that's the timing update. The next update on this is, some people are really excited because Starlink, global coverage, we're going to be able to go all the way north to Alaska. Actually, diving into the FCC filings and stuff, SpaceX is leaving out Alaska from their initial network deployment. They're focusing on 52 degrees north latitude to 52 degrees south latitude. So the poles are being skipped from the very initial phase of Starlink. And that means basically all of Alaska will not have any satellites passing over it. SpaceX does have plans to cover everything, to cover the poles, but those will be a different batch of satellites in slightly different orbits, and no idea how quickly those will be coming. Will they be coming in 2021, sometime, or will it be later? There's actually no information yet on that. So don't count on Starlink being your Alaska connection just quite yet. Now, another thing, speaking of Starlink and coverage maps, the whole architecture of Starlink right now is based on using ground stations. So you got the satellites passing by overhead, and you here in the boonies talking up to the satellite, and then the satellite is basically acting as a relay and bouncing your connection back down to a ground station. So if there's not a ground station in range, the satellite can't talk to anything. It can't do anything. You cannot connect to it. So there will be coverage maps for Starlink at first based on where the ground stations are. Now they're building a lot of ground stations in the United States, and presumably when they launch or shortly thereafter, they will have ground station coverage for basically the bulk of continental United States and spilling over into Canada and Mexico and such. But if you are traveling out to sea or in further afield or in other countries, it could take a long time, potentially a very long time, before these ground stations are in place. And in particularly, crossing an ocean, there's not going to be a ground station in range of the satellites that you're passing through. So SpaceX is not going to be targeting airplanes and boats and far voyagers who are far from sea at first. Now, this is part of their plan and their architecture. They actually have said that they eventually intend for Starlink satellites to have laser connections between each other. So you'll be able to talk to a satellite passing overhead, and that satellite will bounce to another satellite, maybe even to another satellite via lasers, and then get down to a ground station. That'll be amazing. That'll let true coverage be absolutely anywhere on Earth. But that's not baked into the satellites yet. SpaceX has said that they're hoping to have solved the laser problem by the end of 2020 and start working that into their design, but then you'll have to wait until enough satellites have the lasers before they can start turning on true global coverage. So people are excited that they could take Starlink absolutely anywhere, are going to still have to wait a while for the lasers and the ground stations and everything else to deploy around the world. It's not just a matter of getting the satellites over your head. Now, that's the ground stations. Rain on that parade a little bit, but for the United States, that's still a lot of, they're going to have the ground stations covered when they roll this out. But there's now still the question of speeds and capacity. So SpaceX has apparently already demonstrated on a military flight streaming 600 megabits per second over the Starlink network. That is great speed for satellite. And they're saying that they're aiming for under 20 millisecond latencies. So speeds 600 megabits per second, 20 millisecond latencies, that's in really good 4G, that's good 5G territory. That is great performance. But the catch with satellite is anybody who is in your area, the same spot beam coming down from the satellite that you are on, is going to be sharing that same chunk of bandwidth, that same beam from the satellite. And this is just like being in a congested cell tower where everybody around the tower is sharing the tower's chunk of bandwidth. So this means in the remote boonies where there's not a lot of other people around, Starlink has the potential to be revolutionary, bringing more bandwidth than has ever been seen in some of these remote places at incredible speeds, great latencies and all this. But if you get into congested areas, suburbs and cities and places a lot of RVers or boaters converge, suddenly you've got a lot of people sharing that beam, and you are back to dealing with congestion issues. How significant is this going to be? Well, it can prove to be pretty significant, and SpaceX is already laying the groundwork that Starlink is not intended for urban areas. It's not going to have the capacity for that, particularly at first. Over time, once they get to tens of thousands of satellites, they'll be able to, just like having multiple cell towers, divide up the airwaves and divide up the sky to different satellites serving different people, and there'll be more than one satellite overhead, but it will take a long time to do that. And even when there are 30,000 or 40,000 Starlink satellites years down the road, in urban areas and places where there's major congestion, it's always going to be easier to have more capacity coming over cellular that's hooked up to fiber optic, and they could build as many cell towers as needed. So keep that in mind. This is not going to be a use it absolutely everywhere, get amazing connectivity in urban areas. Still, pretty exciting stuff overall. Now, the next big question is, what are you going to need to receive it What's going to be on your end? Are you going to be able to put it on a boat or an RV? What does it take to get the Starlink signal? Elon Musk has been teasing a little bit that they're working on an antenna system that is basically describes as looking like a UFO on a stick. And from their FCC filings, there's not a lot of details, but it's about 19 inches across the UFO part, the size of a good-sized pizza, and then a stick coming up, and it actually has motors on the stick to pivot the UFO to roughly aim towards the right section of the sky. Now, this is actually a bit of a shift from the original vision for Starlink, was that it's going to be able to use a completely non-motorized flat antenna. But the way the architecture of the satellites are working out, it actually needs a little bit of aiming assistance, and that complicates the antenna quite a bit. So we're going to have to see just how reliable and what the costs end up being for this motorized UFO on a stick. Now, inside the UFO, it's still a phased array antenna that is used electronic steering, so it's able to track multiple satellites at once and switch between them without having to aim super fast, but it still needs that general aiming from the motors on the stick, and that introduces the question, and now SpaceX hasn't commented on this, but will this work then on vehicles in motion or boats, even if they're just rocking a little bit? Will the general motors be able to keep up with any motion at all? Now, that makes the more motion the motors can handle, the more expensive the system will be, so maybe they're going to just focus on fixed, still installations at first. Eventually, they might even be able to get back down to the flat antennas, no moving parts, and things like that. But SpaceX is acknowledging, and Elon Musk has been recently saying, that the hardest thing they have to work on is the ground terminal design and getting the costs down, and that it will actually take several years before they're able to kick in the economies of scale. I know, it's sad. These kind of antennas, these phased array antennas, traditionally have cost tens of thousands of dollars to build a phased array antenna. They're traditionally been military technology, so anybody aspiring to bring them down to consumer prices is looking for a major revolution in technology. It could easily happen, but it's a very ambitious undertaking. Don't bet against SpaceX, but don't count on this being affordable and simple and perfect right out the gate before the end of this year. Definitely have to keep this in mind, that they got a lot of work to do. So that's kind of a rundown of some of the trade-offs and catches and the downsides of where SpaceX is at. So to sum it all up, Starlink will likely initially be expensive to acquire unless SpaceX finds ways to subsidize the terminal costs, potentially with long-term contracts, or they're actually working to get government subsidies on this. So might be expensive at first or require contracts. There's going to be network congestion issues. There's going to be gaps in coverage, particularly if you're trying to cross oceans or go into remote places where there's not ground terminals. And there's potentially going to be challenges. This might not be suitable for in-motion usage at first. Now, all of those problems are in the works to be addressed. It might take a year, it might take longer to solve all those issues, but there's plans to how those can be solved. The one thing that keep in mind for satellite is you cannot solve the problem of needing line of sight. So you need to have a clear view between your antenna and the satellites that are passing overhead. And that means you can't be parked in the shade, you can't be parked next to tall buildings, you cannot be in a canyon. This is just the nature of satellites. So people are thinking that they can get Starlink and ditch their cellular. Well, you're in for a rude awakening. That's never going to be the case. Unless you're out in a remote area and you've got a perpetual clear view of the sky, and then maybe Starlink is your everything. But for people who travel and go to a range of places, and urban and suburban and rural and out to sea and everywhere else, you'll probably always need a mix of cellular, satellite, potentially Wi-Fi as well. You'll need an arsenal of connectivity. Starlink, even way down the road, is not going to be the one connectivity solution to rule them all. As much as we wish we could just say, this is it, go get Starlink, it does everything, it's always going to be about balancing all the pieces of a connectivity arsenal. So I hope this gives you kind of a reality check on what is Starlink and what to expect. It's really exciting, but it does have some gotchas you have to understand just to maybe get your enthusiasm dialed back just a bit. Now, we will be tracking this continuously over at the Mobile Internet Resource Center. You can follow our satellite deeper satellite guide at mobileinternetinfo.com/satellite. And of course, we cover this stuff anytime there's news. So follow us there. Take care.
These videos are brought to you by our premium members, our mobile internet aficionados. They make it possible for us to track this news and create these videos. If you like this video, please give it a thumbs up, leave a comment, subscribe to our channel, or better yet, consider becoming a member yourself.